All right, so one more time. Factor theorem, a polynomial f of x has a factor x minus k if and only if f of k equals 0. So what they're saying is this will be a factor as long as when I plug k back into the original equation, I get a 0. They're also saying this is that if and only if that you learned in geometry. If, when I get a value for 0 when I plug in k, is true, then it's going to be a factor. Main thing to notice here is that this is k and this is minus k. We have to switch the signs again. Excuse me. We have to switch the signs again. I know usually with the x we have like x minus h, but this is just saying it's a variable. Whatever the number is, make sure you switch the signs. So, given that this polynomial f of x, excuse me, and we're also going to be given a factor, they would like for us to factor completely. So in order to do that, you have two options. But the main objective here is to get this in smaller terms because we don't actually know how to factor this because we can't do it by grouping because it doesn't quite work out for us. So what we're going to do is use synthetic division. You can do long division if you want. I know some of you have grown quite attached to it, but I'm going to use synthetic division to break this down a little bit further. So my coefficients here are 1, -9, 8, and 60. Now if this is a factor, like 2 is a factor of 6, like 7 is a factor of 49, that means when I divide it, I don't have a remainder. So when I use synthetic division to divide this, I should not get a remainder. Check it right now, excuse me, and make sure. So this is 1, -2, -11, 22, 30, -60, and 0. It's a beautiful thing. That means when I write this out, I'm not going to have to put a plus 0 because my remainder is nothing. So I'm going to start with my constant term, which is 30. It's a positive 30, -11x, and this will be my x squared term. Remember, constant, x squared, and then just keep building from there. Excuse me. So from here, do we know how to factor this? I hope so. You can use box. So remember for your box that your first term goes into your first box and your last term goes into your last box. And now I need two numbers that will multiply to give me 30x squared, and that will add to give me 11x, -11x. The two numbers I'm thinking of are -5x and -6x. So then these two have an x in common. These have -5. From left to right, we have an x, and this is a -6. So, given this factor that we were given here, to write this out in factored form would be to write this as, the first factor they gave me was the x plus 2. That was given. The factors we found were x minus 5 from up top here, and x minus 6 from the side here. This is now factored. You have now factored your first polynomial of degree 3 that you couldn't do by factoring by grouping. Okay, looking at what we just did, try number 2 now. But the only thing I'm going to remind you before I let you loose on this is to switch the sign for your setup. So this is -4. And then carry on. Okay, so I know we did it right because we got a 0 there. And then moving from left to right, from right to left, my constant, my x, and then my x squared. So this is my new polynomial. Then you can use a box, and then you'll find that the two numbers that multiply to give you -3x squared and add to give you 2x are 3 and 1, positive 3 and 1. So those are my factors of this. And then don't forget to bring down the factor that they originally gave you, because if you just started from here, you wouldn't get back to the original equation. From there, you're all good. One more thing before I let you all go. Given polynomial function f, given the polynomial function f and a 0 of f, find all the other zeros. So for this one, it's a little bit backwards from what we were doing. This is saying, this is the if and only if part of it. They're saying, here's my polynomial, and they're saying, here's a 0. What this means is f of -4 is equal to 0. F of -4 is equal to 0. So you're going to need a little bit of space on this one. So if you need to, I'm going to invite you to maybe do this on another sheet of paper, or take out another sheet of paper just in case you write kind of large. Okay, so this is the if, the only if. For here, if you go back up to where we went a little too far. This is when we have a factor, and this is when we have a zero. The zero, we don't have to switch the sign as we did here. So we'll just plug directly in, or directly into the thing. So this is just -4. And then if you could please go ahead and use synthetic division here. Okay, so if you use synthetic division, this is what you should have gotten. And then again, you're going to set up your factor box. You actually might have room for some more of this. But here's the thing, beautiful people. You're finding zeros now. You're not just trying to factor, so you're not going to get your final answer here. This is equal to 0. We're trying to find other zeros, other numbers, so that when I plug them in, I get 0. So your first term goes in your first box, your last term goes in your last box, and then you're looking for two numbers that will multiply to give you -48x squared, and that will add to give you 22x. So one's going to be positive, one's going to be negative. I'm thinking -24x and positive 2x. So -24x here, 2x here, and then you just factor your little hearts away. So this is x. These both have a -8 in common. Looking from left to right, these have a 3 in common, and these two terms have a 2 in common. Excuse me, this was a 3x. So now you're here. 3x plus 2. Maybe you can fit all this on one page. And then x minus 8 is equal to 0. So you'll solve each of these. 3x plus 2 equals 0, and x minus 8 is equal to 0. This one we love because x is equal to 8. Here we're going to subtract 2, 3x is equal to -2, divided by 3, divide by 3, and x is also equal to -2/3. So all of the zeros are 8, -2/3, and don't forget the original one that they gave us, which was up here, -4. What this means is, A, we've solved it, and B, that if I were to plug 8 back into this equation, I should get 0. Don't believe me? You can use synthetic substitution if you wanted to, but I know you believe me because you don't feel like doing it. And you will get a 0. Just like when we plugged in -4 here, though, we got a 0. So if you were to plug in 8 using synthetic division, or -2/3 using synthetic division, you would and will get a 0 here. All right, beautiful people, thank you so much. I do wish you a very Merry Christmas and a very Happy New Year, and I will see you when we all get back from the semester, or I'm sorry, from the winter break. Thank you all. Take care.